Hello everyone, my name is Swasti Jain and I'm currently a second year undergrad in IT and BTech IT. So firstly, we will see this is a tutorial of covering basics of NumPy. So let's get started. So what is NumPy? NumPy is like a scientific calculation library for that is used for scientific computations and data visualization and analysis projects. So we'll be diving into it. NumPy basically consists of NumPy arrays that are mostly used multi-dimensional arrays. And what's the difference between a NumPy array and a Python sequence? So, if we change the size of the NumPy array in the between, the previous ND array will get deleted and then it will create the new array. Unlike the sequences in Python like this, which can move dynamically. And NumPy array consists of all the same data type. Like the data type should be homogeneous valve. Like if a integer array consists of a 1D array, then every element should be a 1D array. Not unlike in Python, we used to store different data types in one single array. And obviously, the plethora of scientific and mathematical Python-based packages are using NumPy arrays. Now, moving forward to the creating NumPy arrays. So, firstly, we import the NumPy library as import NumPy as NP. So, why NP? Like, it will be difficult now to use NumPy again and again. Instead, for the simplification, we use as NP. So we equal to NP dot id 123. We give a list for it, and it will in return gives the array of 1, 2, 3. You can also verify it like by the type of like what's the print type of name. So you can see it's not a usual array. It's a numpy.nd array. It's a specific array, a specific type. So, like moving on 2D and 3D. So, if you pass subsequent list, so the returning number will be a 2D array, and say similarly 3D, 4D, and so on. So, next up, we can specify the data type of NumPy according to our convention, like the type equal to bool or float, anything. Here it is bool, like you can change it to int, so it will like 1, 2, 3. And if you change it to float, it will give like, let's see, 1.5, and moving further ahead in range function and we got range function is works similarly like Python or in range that we used to do, but it's like a equally spaced points. So it gives a range like we are starting from 1 to 11 and we have to jump by 2 by 2. So 1, then 2 plus 3, then 2 plus 7, then 2 plus 9 subsequently. And with the and nextly we have the ratio function. Ratio function, what it does is it converts the size of a if that data remains same, but it converts the rows and columns number according to our choice. Like if you, it's like a range 1 to 60. We want it to ratio into 3 cross 5 matrix. So it does accordingly. And NP zeros and ones are used for initialization and mainly neural networks. NP dot ones, and inside we will pass the dimension of the array. So it will give 1, 1, 1, 1 accordingly, and then period zeros, it will give the 0, 0, and every place it's basically used for initialization purposes. Now NP dot random dot random. Here, first we were accessing a random library with random function inside it. It was randomly generated number between 0 to 1, and the parameter we are passing is the showing the rows by column ratio, like three rows and four columns we want in this case. And next up, the lens space. Lens space is like minus 10 to 10. It gives the series like a AP, like it starts from minus 10 to plus 10, and it divides. And another thing, and another attribute that is written as 10 is therefore dividing the interval into 10 equal parts. So like if minus 10 to 10, and then we have to give 10 numbers which are equidistant from each other, it start by minus 10, minus 8 subsequently. You can like if in 10, in the place of 10, you can change it to uh, another to, you know, experiment like this. And here it is, the five numbers which equidistant from each. And nextly, we have identity. Identity is the same like the identity matrix in the mathematics. Here, the diagonal elements consist of 1 and non-diagonal elements consist of 0. And the 4 gives 4 cross 4 matrix, 3 gives 3 cross 3 matrix, and it is. Next up, we move to array attributes. In array attributes, we firstly areas we have seen and reshape we have seen earlier. Now random. Random is an attribute of numpy which is used to get the number of dimension of an array. What it means is like e2.1 we print it, the dimension of e2 array was 2, if you remember. But like let's see if like previous one that you can see is 3. If you run it, then the answer gives us 3. So it changes accordingly to the dimension of array. Now next up we have the shape. Shape is an attribute of an numpy which is used to get shape of an array. Like, if you have there is an a we have written a shape is 3, 4 rows into column and a row. If you change it like with 3, you can see the difference. 3, 3, 3. Why is it? Like A3 is a, like you can see the A3 array below. But here's a 3 numbers of element. And then in 3 numbers of element, every size has a 3 cross 3 matrix. That's why first 3 representing 3 and the other 3 representing the rows and the columns of each element. And next up we have size of attribute. So what's the size of an attribute? First is size. Here you have the size of an array. It contributes to the total number of elements. And item size represents the how many bits is used by each element. Like A2 is using 8 bytes for each element stored. Next up, we have data type. We can specify the data type according to our need, like here, db3.as type, np.n32. It converts the data type into the n32. We might need sometimes that it doesn't want that long um, data type for our convention, uh, and we can do it accordingly. Next up, we have array operations. In array operation, we have scalar and vector operations. In scalar vector, we have arithmetic like plus, minus, multiplication, etc. So in this case, if we have an array and we multiply it by 2, then each elements get multiplied by the 2. Relational operator compares each element with one condition like A2 equal to 15, greater than 15, less than 15. We can do anything. Next up, we have a vector operation. It usually takes two of them, two of the matrix, and the result given will be divided. Now we have array functions. Array functions have like first up we have maximum, minimum, sum, product. They work according to the name. That will give the product. And here in the axis, what is it? Axis equals 0 means the data comes in the column wise data. Like if you can see, then 44 into 34 into 44 will give 62832, and 65 into 67 into 14, and it will give 6097. So that's how it works. Access 0 and 1 accordingly. And when we have some statistical function like mean, median, standard variation, etc. We can do it. And trigonometric function also, sine, cos, tan, and we can do dot product also. In dot product, we have to provide the two attributes with a given array like A2, A3 accordingly. And we have log and exponents also. And we got exponent, it will take the exponent of each and every term and result accordingly. Now we have flow round, floor seal. We can see round will round up the particular number to the nearest integer, and same with the floor and seal, with they can floor value and the seal value. It's like a 4.1, then the floor value is 4, and then if for the same 4.1, the seal value will be 5. And you see. Next up, we have indexing and slicing. In the indexing, we are like section. We are locating the data according to its position. Like if you see it, if we want to check the four, how will you do it? The first, we will first do the row name, then it's one, and then we will get the column name. Let's see accordingly. And the same with the 3D matrix, it takes three attributes to identify one. And these are some practice question. You can do it. And further, we have next topic is iteration. Iteration, like so it's same as in a for loop we did earlier, we do in Python. So for I in A1, print I, etc. And the point to remember here is in 1D array, it is a particular element by if we iterate. In 2D array, it gives 1D array in one time. One and in a 3D, it gives 2D in like at a time. So here you can see. And if we want like I want to operate on each element, then there's a function for you as a for I in NP dot NP it operates on each element accordingly. And then reshaping, we have studied advanced. And transpose is mainly used. Antidote transpose, and in transpose, we give the parameter as the array which we want to be transposed of. And it has a simple trick also, E2.P. It directly gives the transport because it's mainly used. And next level. Now, what's the difference between the level and the endiator? In the endiator, like you can perform the different type of action on every element, but and Ravel, you just take it gives only the one any area to one D area. Now stacking. Stacking, I will show you in the stacking. If you have let's say in stacking, if you say you have a 3 cross 3 matrix and one other 3 cross 3 matrix. If we stack it horizontally, what will be there? If we stack it horizontally, it will stack side by side like this, and the resultant would be something like the whole matrix, and this dimension of it will be like 3 cross 6. Okay, and if the same you do with vertical vertical stacking, in vertical stacking, what you will do is let's say the same example. If you have one is 3 cross 3 and another one is 3 cross 3, and if you vertically stack them, the resultant would be like something like 3, 1 in above. So the final matrix, this is also 3 cross 3. And the final will be like something like the whole, and then the matrix we would have with 6 cross 3. So it's like vertical stacking. Now, if now we will talk about the stacking for horizontal stacking use H stack function. It picks the two array which we are using to stack, horizontally, and vertical stacking takes the V stack function. And now splitting. Splitting is interesting. If you see here in splitting, if you want to split an array, let's say it's a 3, 2 cross 4. Okay, so it will be like 2, 2, like, so sorry, one low, you take 3 cross 4, 1, 2, 3, 4. It's like this. So if you split it horizontally, it will split like this. And the resultant, you will have a 2, you know, array, one of 3 cross 2, and one of 3 cross 2. So it's a vice versa. In horizontal array, you do in horizontal splitting, you do vertical line, and in simultaneously in the whole like if you want to split this array like vertically, then you will how you will do vertically. So vertically, sorry, the wrong diagram. Also, you also in if you want to split it vertically, then you will divide it by horizontal line. So, like if this from matrix would have considered of 2 cross 4, which is sorry 4 cross 4, then the resultant 2 would be the resultant 2 would be consist of, oh sorry, 2 cross 2 and another of 2 cross 2. Okay, and that's how vertical and mm, vertical and horizontal splitting works. So the function for it is HS horizontal for horizontal split is H split, and for vertical split it is V split, and yeah, that's for it's for the basics of the MATLAB. I hope I can provide you some value for in your knowledge, and thanks for watching.